Hello everyone. Now I am going to discuss about various concentration terms which are discussed in the first lesson or in the solution lesson. So we have totally approximately five concentration terms. So namely molarity, normality, molality, mole fraction and ppm. Okay. So molarity means we already dealt with what is mole. Mole is Avogadro number of particles or atoms or molecules of the given constituents, right? So you know how to calculate 1 mole. So if you take 1 mole of any substance and when you dissolve it in 1 liter of the solvent, so that is known as the molarity of the solution. So it is represented by capital M. So capital M, it is given mole divided by given volume of the solution in ml. If you want to convert into the per liter, you have to multiply with the 1000. Okay, so what is number of moles? Given weight by molecular weight, that is number of moles, and this 1000 by V carries here. So this is the formula. So molarity is equal to given weight by molecular weight into 1000 by given volume. So you can calculate the molarity of the solution, or if you know the number of moles and the number of if you know the volume of the solution or solvent, you can directly calculate using this formula. So two formulas are given. Similarly, if you have normality, how to calculate normality? So you know that how to calculate the equivalent weight for the acid means what? So molecular weight of the acid divided by the number of replaceable H plus ions present in the given acid, or molecular weight divided by basicity we call. Okay, so in that way we can calculate the equivalent weight of the acid. Similarly, for equivalent weight of the base is molecular weight of the base divided by number of replaceable OH minus ion present in that base. So we calculate accordingly. Similarly, salts means how many charges are either cationic charges or total anionic charges. Molecular weight divided by the charge. One charge you have to take, either total cationic charges or total anionic charges. If you divide it, you will get the equivalent weight of the salt. For oxidizing agent or redox agent, how do you calculate how many number of electrons are transferred in that reaction? So molecular weight divided by number of electron transferred. Accordingly, you can calculate that particular oxidizing agent or reducing agent's equivalent weight. So if you know the equivalent weight and that much amount, if you weigh it, that we call it as a gram equivalence. If you dissolve that gram equivalence in 1 liter, that is known as a normality. In molarity, we take 1 mole or molecular weight, that much amount if you take it, that is 1 mole. When you dissolve it in 1 liter, you get the molarity. In the case of normality, you just measure the amount of equivalent weight, that is known as a gram equivalence divided by 1 liter. That is mole by 1 liter is molarity, gram equivalence by 1 liter is the normality. So gram equivalence, it is nothing but weight by equivalent weight by given volume is into 1000. So that 1000 by V it carries here. So if you know how to calculate the gram equivalence and the given volume, you can directly calculate the normality using this formula. If they have given the weight and the equivalent weight and the given volume, so using this formula also we can calculate the normality. Okay. So here in both the cases, molarity and normality, we have taken some weight divided by we dissolve in a volume of the solvent or solution. But in the case of molality, we take solute also in weight and solvent also in weight. Okay, weight by weight. For example, previously when we go to the shop, we ask 1 liter of gingerly oil. Now we ask 1 kilogram of gingerly oil. So in that way, what we are going to do is we take a given number of moles of the solute divided by 1 kilogram of the solvent instead of 1 liter of the solvent. So that is molality, small m. So number of moles dissolved in 1 kilogram of the solvent or solution is known as the molality. So number of moles that we know, that is W by capital M. This small w is for the solute, capital W is for the solvent weight. weight. Okay, so it's a weight by weight. Here the small w is the weight of the given solute, capital M is the molecular weight of the solute, and the capital W is the weight of the solvent. That always we take it as a 1 kilogram, or if they are given the some other kilogram, for 1 kilogram you can use this formula and you can get the given molality of the solution for the given details. Next one is the mole fraction. This is also weight by weight. So what is mole? Mole is given weight by molecular weight, that is moles. Suppose if we have two components, if I have something like I have sugar as well as the water, so I have to calculate the how many number of moles of water is there, how many number of moles of sugar is there. So and then I have to sum the both the moles of sugar and water, that is total moles. Now I have to take the ratio of the mole fraction is given moles of that particular component divided by total moles. So similarly, if we have A and B components, so mole fraction of A is number of moles of A divided by total number of moles. The mole fraction of B is number of moles of B divided by total number of moles. That is, only you have two components, so the total mole is Na plus Nb. So always the mole fraction X, if you sum it up, it is always 1. Okay, so for two components, you can have three components as well, but for in the case of solution, you have solute and a solvent, so only you can have the two components. Okay, so what is 1 demol? If you take 1 mole in 1 liter at 0 degrees Celsius, that is known as 1 demol. And we can also know the another concentration term, percentage of the solution, that the biology students use that. So percentage of the solution, suppose if I need 10% of sucrose, what I have to do is I have to take 10 gram in 100 ml, 10 gram of the sucrose in the 100 ml. Okay, if I need something like 2% of sodium chloride, so independent of whatever the molecular weight or equivalent weight, so I don't know all those things, I just take those many grams and I dissolve in 100 ml, that is known as the percentage of the solution. Then the biology student, one more thing they'll, or even chemist people in the water lab or some other, when the concentration is very low, they use the terminology called ppm. So what is ppm? 1 part in 1 million. That is, if how I can measure practically, if I take 1 milligram substance and I dissolve it in 1 liter, so 1 milligram is, what is 1 milligram? 10 to the power minus 3 gram in 1 liter. So if I send this bottom, so 1 gram in 1000 liter is known as, or 10 to the power 6 ml is known as the parts per million. 1 gram in 10 to the power 6 ml is known as the parts per million. So general formula is mass of the solute divided by mass of the solution, which means mass of the solute plus solvent is the mass of the solution into 10 to the power 6. Using this formula, we can calculate the parts per million. Hope you understood all these various concentration terms. So this one we need it for the calculation of various concentration terms of the given solutions. For example, molarity calculation, normality calculation, and so on. You can use this formula. Hope you understood. Thank you.